Now, welcome to the 2019 Paper 1 of the Junior Sir Higher Level. So, I'm just going to get started here now on question 6. Apologies. So, if you want to set this, copy the set notes I'm working off, just send me an email at shanetroy@gmail.com, or the email address should be in the description below. Now, this question here is the question 6 of the Paper 1, and it's worth taking a go with this yourself, okay, and see how far you can get. But question 6 here, okay, it's got a lot of time allotted to it, but this part A and B, which are mixed together, have a lot of marks. So let's see if we can figure out what's happening in this graph before we do anything, and then have a go at it. So this bottom part here, the x-axis is not x, but it's the d-axis. So it describes distance. And then here on what would be the normally be the y-axis, we have time. Okay, now it's kind of weird because this is a distance time graph, but it's kind of inverted. Normally we'd expect the distance to be on the y-axis and the time to be on the equivalent of the x-axis. So it's a bit weird, and it caught me out there when I first saw it. So if you think here what's happening, okay, rise over run describes the change of one variable to another. So this is showing the change of the time relative to the change of distance. Okay, so with rise over run, okay, we can do that. Would be the rise there would be 8 units over the 2, which would be give you an answer of 4. Now that's 4 minutes per kilometer. Okay, so 4 minutes to do 1 kilometer, which is kind of opposite of speed. If you flip that over, okay, it'd be a quarter kilometers per minute. Okay, so the different way to look at that would be to kind of go, well, what distance did they run? Okay, was 2 over how long was 8. Kind of inverted rise over run, and that'd be equivalent to a quarter. Okay, so that's basically what's happening here. So let's get stuck into the question. And you can read yourself there. Both Poppy and Ella ran a 5k race. The simplified graph below shows the time that it took Ella to run d kilometers during the race. One of the points in the graph is marked A. So Ella was running this and then this. So if you said we worked out that was 1 over 4 was this bit. Okay, so this is looking like 3. So that distance there over 26 as far as 8. The difference of 16, but we do 18. So 3 over 18, which is equivalent to 1 over 6. Okay, so 1 kilometer in 6 minutes. Okay, so she's going faster here. 1 kilometer in 4 minutes is faster than 1 kilometer in 6 minutes. Now, I think that's useful to us later on. Well, let's get stuck into what's actually asking us for these first 2 parts. It says the table below shows the total time that took Poppy and Ella to run each of the given distances. Use the figure in the table below to draw a graph that shows the time it took Poppy to run d kilometers during the race. And then there's all this fluff here. Now, really none of that matters. Okay, it's just stating what's in the graph. But they have to kind of cover themselves by saying that in order to be mathematically correct. So we're trying to here graph what happened to Poppy. So after 1 kilometer, so here, she had run or taken her 5 minutes, which is that point there. Then 2 is equivalent to 10. So it's basically plotting the values of d versus time. Okay, so the x value is equivalent to this one, and the y value is equivalent here. So the x value of 3 corresponds with 13. So 3 is somewhere up here, and so 17 is, I think, there. Then if you see the rest of them, so if we go to the answer, that's the graph drawn there. Okay, just plot those points. Okay, and it ends there. So then the part B says, fill in the table here with the total time taken for Ella. Now they give us 2 different ones. They give us after 1 minute she ran 4. Okay, now that's the original graph here. So you see that's 1 and 4. The last one there, after 5 minutes she ran 26. That's that one, that value there. They want the other 3 in between. So 2 was 8, 3 is 14, and 4 is the 20. I've written the values down here in the table. Happy days, 15 marks. So if we move on to part C there, it says, show that Poppy's times in the table do not make a quadratic sequence. Now, if something is linear, it may have a constant first difference. If something is quadratic, it'll have a common second difference. So let's see here. Okay, so you have the different values here. First difference there between 5 and 10 is 5. Between 10 and 7 is 17. Between 17 and 24 is 8, 4, 5, 6, 4, 5, 6, actually 7. Between 24 and 30 is 6. So the first difference is not constant, so it's not linear, okay, because it changes. Second difference between 5 and 7 is 2, 7 and 7 is 0, 7 and 6 is 1. So it's not a common second difference, therefore not quadratic. Okay, and that's basically what I'm stating here in the answer. Okay, so the data or whatever, first difference and second difference. And that's comes up commonly in junior or honours, so you need to kind of be aware of that fact. If it does come up, you'll have a strategy in order to find the answer. So that's part C. Now part D and E here are marked together and worth 10 marks. It says it took Ella 26 minutes to run the 5 kilometres. Work out Ella's average speed. Now we know that speed is equal to distance over time. Okay. Now her distance was 5. But her time, now we want in kilometres per hour. We're given 26 minutes is not per hour. But we can change that to per hour by dividing it by 60. And that becomes the equivalent of like 13 over 30. So if we divided by the 5 divided by time, you could go decimal here if you wanted, but I'm going to keep the 26 over 60. Okay. And I want to kind of, in a sense, simplify that. Now I can do it by hand. No harm having the practice to do it by hand. Okay. And we'll try get, so that's the equivalent to 5 over 1 divided by 26 over 60. So you're creating a fraction on top in order to apply the fraction rule of dividing. So fraction divided by fraction, you take the bottom fraction and turn it upside down, and you multiply it by the top fraction. So 5 over 1 times that. Now fraction by fraction is 5 over 60 is 300. Bottom by bottom, 1 over 26 is 26. And you simplify down or go decimal. Okay, I have the answer over here. That's the decimal equivalent there. And I think it's already rounded. I forget exactly from when I used the calculator to do it. But if it isn't rounded already, just look at the third decimal place. If it's 5 or greater, bring the next one up. Or lower than 5, keep it the same. So the normal rules of rounding. It's worth being aware of these 3 formulas and just memorizing them in case it happens. So part E there says tick the box to show what happened to Ella's speed after 2 kilometers, which is marked X on the graph. So if we kind of go back to remind ourselves of the graph, okay, that was the first one there. So Ella's speed there was 1 kilometer in 4 minutes. Here, if you remember, it was 1 in 6 minutes. What happened? She slowed down. Okay, so we did say that would be probably important, and it was. So Ella's speed decreased. Okay, why? Now, if you can give reasons, okay, figures, you can prove it directly. She did run 1 kilometer in 4 minutes. That's whatever. Then she slowed down to 1 in 6 minutes, so that is slower. Okay. Now, again, the speed distance thing here is weird in that normally the graph is oriented differently. So it is going to be a step harder than normal. Now, part F and G there, okay, it says Kieran also ran the 5K race. He drew the graph below to show the time it took him to run D kilometers during the race. The part of Kieran's graph marked C is a vertical line. So if your distance isn't changing and time is happening, that means you've stopped. That's the first thing. But again, the graph is oriented weirdly. Okay. Now, I'm working off a tablet, so I'll probably just turn it up the other way. Part F is saying, what does part C tell us about Kieran's running at this stage of the race? No, so that's the answer. He stopped because his distance isn't changing, but time is. Like, we can't stop time, but I can stop moving. If I stop moving, time still passes, and my distance is 0 kilometers, whatever, per maybe 1 hour, okay, that's 0. So I've stopped. My speed is 0. Now the second part G, Brendan says Kieran's graph does not show total time as a function of distance. Give a reason why Brendan is correct. Okay, so Kieran's graph does not show total time as a function of distance. Let's go through the answer. Okay, so I'm saying here an input distance can only have one output, okay, for a function. So basically, okay, so now that I figured it out, basically what is said is that with any equation, you can't have two values of y. Okay, so if this is the y-axis and this is the x-axis, if it is a function, there's going to be one output for one input. So 2 there is going in, but there's multiple outputs all the way along there. Okay. Now, in fairness, that's fairly challenging. If you know your stuff and you really understand your graph, you have a fairly good chance of getting something decent. But it's fairly hard. The part F there should be pretty okay. So remember, usually with a question like this, although you won't know in advance, if you get one part right, you usually get the mid or probably the high partial. So you're doing pretty well, okay? But you won't know that the question is going to be marked like this when the marking scheme isn't set. So that's question 6. Okay, so thanks very much and see you on question 7.